Alright guys, so right now we have a 2012 Santa Fe customer complain about parasitic draw. The way I heard from advisor that since they replaced from our shop the alternator and the battery, um, they replaced from the previous year 4 times the battery. So of course we're gonna use our thermal imager. Let's see, at least it's been sitting for the whole weekend, and see which one is turning on. So right now I'm just here inside the cabin or inside the car. You know, let me open the hood. So here's our hood open. So I'm just gonna go through all these components here. Um, the way I can see, it's not detecting at all. And there's a red mark there because that's a car. Maybe they just parked it earlier. Um, yeah, unless our battery is dead now, right? I think our battery is dead now. So let me try to start it. If the battery is dead, for sure there's no more power going into that suspected module or component that's drawing the power. So um, yeah, let me grab the key and let me try to start this vehicle. Okay, I can see the beeping. I can hear it. Okay, okay, it started. What we're gonna do next is, I think what we're gonna do is, I'm gonna drive it inside the shop, and let's see. It didn't pick up on our, what do you call that, on our thermal imager, and let's see if we can find it using our amp clamp. Okay, so before we do our parasitic growth testing, we're gonna inspect our battery first, make sure it's in good condition. I know the customer mentioned that they replaced 4 times already. So I have this Midtronics battery tester. There's a regular, I'm using 700. So it says good battery. We have 688 CCA. Okay, so now what we're gonna do is I'm gonna set up my amp clamp, and we're gonna see our current draw. And same thing in my previous video, like the ecos. I think we're gonna set up the vehicle, open all doors, and the hood. Gonna lock it, and then so that it's ready for um, to lock the vehicle. So I'm just setting up right now. My scope here, small scope here, is the battery is low already, so I hope we can capture it before this one dies. If not, I'm just gonna use the multimeter or my other scope. And I mentioned already before why I want to use this kind of setup, because you can see visually, right? Unlike the multimeter is just number. If you have no choice, yeah, you can use the multimeter. But if not, yeah, as much as possible, it's either you have a graphing meter or this one, so that at least you can see um, the drop, right? So same thing, I'm using the 20 amp output, so in every 100 millivolts, that's 1 amp. And we're just gonna clamp it there. So I'm just gonna try testing our unlock button. So it went down, so I'm just gonna reverse this. Unlock, so it went up. As you can see there, there's a current that went up, so which is good. Now we're gonna be um, locking all our doors to make sure that everything is set up before we're gonna start monitoring our current draw. Second take. Up. Okay, so that's locked. Our driver's side. Let me unlock this guy. And same thing, we get our door switch there. I'm just gonna remove this guy here. I'm just gonna open this. So when I open the toll gate, our interior lights came on. So I'm just gonna lock this again. And then I'm gonna remove this passenger side just in case we have a fuse box on the other side. It's off already. Okay, so I'm gonna try to lock this guy here. But how come it's not beeping? Something is still missing. We're still missing something. What is it? Because that should beep, you know? Okay, so on these models, guys, we get our hood switch. It's not on the latch, so we don't have to lock this. We just have to, it's either you press this guy or remove the connector. So we're just gonna be removing the connector. I think that's easier. Okay, and we should be ready now. So I'm just gonna unlock it again. Okay, then I'm gonna lock it. Okay, that's what I want when it locks, right? But right now, as I can see here, it's reading 0. Okay, one tap. I'm gonna lock it. And it dropped to 0 right away. Hmm. Mm-hmm. Okay. So I'm just gonna leave it like that, just in case something is waking up the module, right? Maybe we can find something in there, and we'll see. Okay, so as of now, we don't. I think I don't see any um, draw there. So what I'm gonna do is maybe I'm gonna double check also the recording because I left it for how many minutes? Maybe 15 minutes. So I'm gonna check the recording. Maybe there's some spikes there. If not, what we're gonna do is I'm gonna try to do a full system um, test, like you know, cranking test, charging voltage test, and everything, and we'll see. Okay, so we're gonna do a testing right now. I'm gonna ask someone to to start the car and turn on the loads and everything. So as of right now, we got 2.49 volts. What always they're saying is the fully charged battery is 12.6. So I'm gonna ask someone to start the car. Can you start the car? Let's see the charging voltage first. Okay, so right now we're charging at 14.6 around there, right? So grab it at 2,500. So at 2,500, we're reading at 14.62. Okay. Now try to turn on all the loads. Blower, high beam, rear defogger. Turn on, turn on. Okay, whenever all loads are on, we have at least 14, 13.9, 14.1. So I'm gonna ask the driver again to rev the engine. 2,500. Okay. So most likely, um, our charging voltage are stable, right? Nothing's going on there. Okay, turn off everything. Off, off. So, I don't know, you heard that too. When the first start up, the engine was so noisy. Um, so yeah, so charging voltage is good. The battery testing was passed because I think this is new. I think I have to gather more information regarding um, when that battery drain happens because as per the customer it only happens when they park the vehicle after weekend, right? Unless they're not driving it often or long drive at least to have the time to charge the battery again. So yeah, so far everything is okay as of now. um, let me see that. Because this new Santa Fe, this Santa Fe has also problems with the alternator, um, with the leak. But I don't know if this model has this. So far, our alternator is dry there, no oil leak at all. Um, so yeah, I'm just gonna ask my advisor again to ask for more information, I guess, or we have to leave the car here again and see. Alright guys, so we're just measuring now the AC ripple, just to cover our bases that we know that the car, or they replace it with aftermarket alternator and battery. So our blue will be our AC signal and the red will be our um, DC voltage. So on our scope, here's gonna be the reading, right? So I'm just gonna start the vehicle. Where's the key? Okay. So first we're just gonna let it idle and see what's going on. So right now we have this pattern now on the AC. What they're saying is at least a good 200 peak to peak, meaning from 0 to up, that's 200 millivolts, and 0 to down, 200 millivolts. So as you can see there, that's not stable at all, right? And we're gonna try to put some load on it and raise the RPM. So I'm just raising it to 1500 to 2000. Hold it there, and we'll see the pattern now. Okay, so I'm gonna turn this off.
I'm gonna change the your car.
So, let me just stop this. So we're gonna go back. So this is the time when we rev it, right? 1500. And if I'm just gonna measure it, we're reading around, it's 400 millivolts, just the from 0, right? So if I'm gonna go the difference between them, peak to peak, that's around 700 millivolts. That's too much ripple. So and then if we can zoom in here, as you can see, there's a drop out there, which is not good, because the normal waveform for the AC ripple will be more or less like this, right? Let me zoom in here, like that, an amp. So why we're doing this? Because with a bad AC, or if there's a leak on the AC voltage, it's not clean DC voltage, we're gonna have some problems, right? Could be that even though we're seeing here on the red voltage here running, it's reading 14.6 volts in there, even though that voltage on the charging system is good, but we have some issue with our AC, right? So what I'm gonna do next is I'm gonna transfer our red leads here to our positive connection there in our alternator, because the best testing on this one is on the alternator, right? Because your battery is like a, what do you call that, it absorbs or clean the signals. So we're gonna compare both signals from blue and the red. So the red one I'm just gonna put in our positive side on the alternator on this side here, and the ground will be on the alternator case, right? So I'm just gonna move that and let's check again. So I can't use my clamp on the positive, so I'm just using a lead right now, and then we'll just review our capture later in the scope. So I'm just gonna use this. Okay. Huh. It's so hard. And so right now I'm on the positive post on the alternator. Okay, try putting a load, headlight, high beam, defogger AC. And then 2000 RPM. Okay, off. Okay, so now we're gonna go to the scope capture and let's see what's going on there. Okay, so we're just gonna go to our capture again. Okay, so I think this is when I made my connection. As you can see here on our blue, that's on our battery post, right? There's too much there, AC ripple. So I'm gonna measure again. And that's peak to peak 700 millivolts AC. And when I'm gonna go there to our positive post itself, or not positive post, positive terminal on the alternator. Oh, that's too much. Let me separate this. As you can see there, it should be even amp. This one goes amp and there's a dropout. And for the measurement on this one is, let me see here, peak to peak. Oh, that's a lot. So peak to peak, we're measuring at least 1 volt AC. So from 0, the top one, 0, peak to peak, that's gonna be 350 millivolt AC, and then for the bottom one will be 700 millivolts. That's too much. So I think we have a bad alternator in this one, even though that, you know, we have a charging voltage of 14.6. So on this side here, this is when I made a good connection. See, this pattern here is all even. I think this is one alternator. The same thing here, as you can see there, it's bad there. How about this side? In here, and same thing on the reading on the positive side, or positive side, on the battery side. So on the battery side, so testing this is most likely, right, or the best location to do the testing is you go to the battery, oh no, the alternator terminal. But in this case, like, it's so hard, the location itself, I use the battery first and see, and we have some problem there. We know that there's a problem. Now we just want to confirm it on our positive post there on our alternator. So I guess what I'm thinking right now is I'm gonna upsell a new alternator and let's redo our test if the customer is going ahead about this concern, and we'll see. If not, I think we learned something today on this video, that we got an alternator problem or an AC leak voltage problem, even though our charging voltage is showing 14.6 volts. So that can cause problems, right? Because the alternator is just to provide DC voltage, which is needed for the modules, for the battery, right? So that's the purpose of the alternator. But if there's an AC in there riding or leaking, that's gonna be another problem. So we'll see.